I wanted to do a quick video of the practice problems on page 269 from section 5.1, especially for the people who were geometry testing instead of in class when we went over these. So for question 1, it's asking you to calculate the average atomic mass. And so when you actually have to calculate the atomic mass, you need a couple of pieces of information. So you need the actual mass, and you use the mass, not the mass number. Okay, the mass number is just an identifier for the isotope, but we're actually going to use the mass. And then you also need the percentages. But you have to remember that in math, when we do calculations with percentages, we move the decimal over 2 places on those percentages. So that becomes 0.6011 and 0.3989 for those calculations. So what we do here, you should notice this is 6 significant figures and only 4 significant figures on the percentages. So our final average atomic mass will have 4 significant figures. Okay, so the formula for average atomic mass, it's not super clear in the reading, so let's just write it out very clearly. Average atomic mass is mass isotope 1 times percent of that isotope plus mass of isotope 2 times percent of isotope 2. So that's kind of where everything's going to come from. So if we do this, mass of isotope 1, that's gallium-69, is 68.9256 times its percentage, which I'm going to use now as a decimal because I'm calculating with the percentage, so I always do that, plus mass of isotope 2, 70.9247, that's a 4, times its percentage, which is 0.3989. Now, before we do anything in the calculator, I want you to look a little logically here. So this is about 69. This is about 71. If we had equal amounts of them, they would average out to be right in the middle, 70. I have slightly more of the 69 than I do of the 71. So my average should be slightly closer to the 69 value than it would be to the 71 value. So instead of 70, I'm going to be pulled a little bit closer to 69. So that's how you kind of use estimation to do this. All right, so if you enter this in your calculator, you should enter it exactly the way I have written, using the parentheses and everything. So you'd be open parentheses 68.9256 times 0.6011, close parentheses, plus open parentheses 70.9247 times 0.3989, close parentheses. When you do all that, your calculator is going to spit out this nice long answer, 69.72304099, which is great and all, except I want it to, as we said, 4 sig figs, so it's just 1, 2, 3, chop it off there. This 3 does not make me round up, so my answer would be 69.72 AMU is my unit up here, so that's going to be my answer. So that's what I have, and that should make sense because, again, if it was smack in the middle, it would have been 70. But I have more of the 69, so it should be slightly less than that, and that is what I have. So that's good. Okay, so the next problem. This is a little bit more complicated. This is what makes this more of an honors or an AP sort of question. This is a question where, you know what? They didn't give me the percentages. You see no percentages here. That's what they want me to calculate. They want me to calculate those percentages. And instead, I have the atomic mass already. I have the answer to the question, right? I have the average mass equals mass times percent, which I don't know, plus mass times percent, which I don't know. Well, if we don't know something in math, we set it as x. But I can't set these both as x because they're not the same percentage. If they were the same percentage, this number would be smack in the middle, and it's not. So I don't want to use an x and a y because that overly complicates my math. So I want to use an x for 1, and I basically want to use a system of equations here to make this work out easy. And since I'm dealing with percentages, I can make that easy because I know that 100% is equal to one of my percents plus my other percent. But I don't use percentages, I use decimals. So 100% as a decimal is actually boom, boom, 1. So 1 is going to be equal to one of my percent as a decimal plus my other percent as a decimal. And I'm going to use that fact. So I'm going to set one of these as x and one of these as 1 minus x. And that's going to make it all work. So it doesn't matter which one you set as x and which one you set as 1 minus x, but if you don't like dealing with negative numbers, and most of us don't like dealing with negative numbers when we're doing long written out algebra, the easiest way to do it is always assign x to the heavy isotope. And that'll save you a lot of trouble. And then you're going to assign 1 minus x to the light isotope. Okay? So, and again, if I add together x and 1 minus x, I'm going to get 1, which is 100%. Nifty trick from percentages. Okay, so to set all this up, I'm going to work out all the algebra. This is what I did in class. So 35.453 equals my mass, which is 34.9689, times that percentage. Well, that's the light isotope, so that's 1 minus x, plus my other mass, 36.9659, times my other percentage, which is x. Okay, so you're gonna have to bear with me because I'm gonna switch pen colors a lot so you can follow what I'm doing. So this is multiplication, this is addition, this is multiplication across parentheses. So you have to think through your proper steps algebraically. Between addition, multiplication, and distribution across parentheses, what do you have to do first? You have to do the distribution. So this number is going to distribute to both the 1 and to the negative x. In theory, this one will too, but there's nothing else there, so they just kind of combine. Okay, so now let's rewrite what we've got here. So I'm going to stick with the blue. Okay, so I'm going to rewrite each step. So 35.453. Multiply that across. 34.9689 times 1 is just 34.9689. But when I have that negative x, that's going to be a negative 34.9689x. All right, so plus this distribution here, well, that didn't do anything too interesting. 36.96559x. Okay, so I have a number value, a number value, a number with x value, and a number with x value. So the next thing I have to do is collect like terms, but you need to identify what those like terms are. So that's a number, that's a number. And that's a number with an x, that's a number with an x. So I need to combine the two black things and I need to combine the two red things. So I'm going to move the two black things onto the left-hand side because I already have one over there. And so what's the proper algebraic manipulation to do that? Well, this is all addition and subtraction. So I have to do the inverse operation of that. So this is a positive 34.9689. So I need to subtract that off. Okay? I And I'm just realizing I ended up with an extra 5 in here somewhere. Whew, strange. Okay, so I need to subtract 34.9689 and subtract 34. That's a 4 again. 9689. So those cancel out. Once I do that subtraction right there, I'm going to get 0.4841. So that's what I have on that side. And here, that's a negative 34.9689 and a positive 36.9659. I can simply combine those two things in the calculator. Negative 34 blah 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 and positive 36 blah blah blah. I should get a positive answer, and it should be around 2, and in fact it is positive 1.997x. Okay, so I just went from a whole lot of stuff to very little stuff. That's good. So I still have my x over here. I still want to get my x by itself. It is attached to a number. I have to get rid of that number. It is multiplied by it, so I have to divide by it. 1.997, 1.997. Those are going to cancel out, and now I'm going to get a magical number, x. I need 4 significant figures as you've been following through, and I'm going to get 0.2424. Am I done with the problem? No, because I had an x, and I've got that, but I don't have my 1 minus x. So 1 minus 0.2424 equals 0.7576. Great! Now I'm done, right? Nope. These are decimals. I don't want decimals. It asked me for percentages, right? Percents. So I have to put these in percents. So bump, 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 bump. So this is 24.24%. And this is 75.76%. And who does this 24.24% belong to? It belongs to the heavy isotope. My heavy isotope is this. So this is 37 Cl. The 75.76 was from my 1 minus X, which is the light isotope, which is this. The chlorine 35. So this would be my answer here. So these two problems are going to match problem number 8 and problem number 10 on the review questions for section 5.1, which I want you to have done so we can go over them in class, next class period. Thank you.